Good morning, everybody. Welcome to physics. This is the last section of one-dimensional motion, and it's free fall. So then free fall would be something that's under the influence of the force of gravity and no other forces at that time. So when we do these problems, there is no air friction involved. But since he said that, just so you know, fluid friction, which air is fluid, the force of that is related to it's exponential relation to the velocity. But we're not going to be doing that. What we're going to be doing is something that you might expect on the moon, except for the gravity is going to be less. First of all, little g is acceleration due to gravity. And for our purposes, we use 10 for the number. Kind of the accepted value at sea level on average around the Earth is 9.81. But there are different anomalies all over the place. We use 10 because we use it so often that we can do this math in our head really easily. And the OK has been given by College Board since the front page of their test says, go ahead and use 10 for acceleration due to gravity. I have had kids in the past use 9.81 only for a couple months, and then they realize that it really doesn't matter. As long as you know how to do the physics, that's what counts. So, first of all, when we throw something up, we need to look at the symmetry. So now we're actually talking about one-dimensional motion, so this would all be better in line, but I can't really talk about different pieces of it that way. Okay? But everything I talk about today will also be true for the next chapter, which is two-dimensional motion. So if you don't understand something, you better make sure that you understand it before we go on. If we have a velocity of 14 meters per second in that direction, can you tell me how long it'll take to get to the top without even doing any math? Well, any written math. How long is it going to take? 1.4 seconds to get to the top, right? Because the acceleration is 10. And we know that the acceleration towards the Earth then would be in that direction, right? So it's slowing it down. You've done so much with this stuff. You should know this. How long is it going to take to get down there? How much time from the top to the bottom? Another 1.4 seconds, right? So this is kind of the discussion we've been having the last week. So there's this like big symmetry thing going on. Not the velocity is the same, but what is the same about these two pieces as long as they're on the same x plane? The speed, right? So the speed is exactly the same. So if we were up at this point, let's say maybe we are going 5 meters per second on the same x plane, on the other side of the trajectory, we would have 5 meters per second. Difference is it'd be in the opposite direction, right? So, if I was talking about this question, and I was talking about little g, or acceleration due to gravity, what sign would I put on that number? Positive or negative? Negative, right? Because we said right here, when we first started talking about this question, that this was a positive number, because there's no negative. It's assumed that it's positive, there's no negative. Okay, so you have to make sure, without a doubt, that whatever convention you decide, the opposite is a negative number. Okay, so if you say something's positive, the opposite's negative. Hey, I got a question for you. Is there acceleration up here at the top of the trajectory? Well, yes, there is. We talked about this a lot of times. Have you ever jumped up and just stayed there? No. So this is also negative 10 in the same direction as always been. The acceleration is caused by the force is always towards the Earth. So regardless, we're going to have an acceleration, or little g, equal to 10 in all parts of this motion. And that's what we were studying last week. So you really need to keep in mind that acceleration due to gravity does not change, because it's the Earth that's pulling us. Now, if we went to the moon, it'd be a smaller number, right? Well, talk about that later. So there's this symmetry. So if it took 1.4 seconds, I'm going to go up a total displacement of x. And 1.4 seconds, I'll have the same displacement of x because the velocity at the top is always 0. So I could call v sub naught if I'm dropping it. I could call v if I'm throwing it up. Or I could, if I'm having a problem throwing it up to figure something out, I could just go up here and I'll just pretend like I drop it because I know everything on the way up is the same as everything on the way down. You really have to grasp that concept. It's a beautiful symmetry. Of course, it's not quite this way in real life. Like, we humans would love it to be because we're symmetrical. We think everything should be, but nothing is. Okay, so let's see how this works for some math examples then, so you can do the math. Free fall examples. Okay, so I'm falling off the edge of a cliff. 5 seconds is the time. My displacement is what I'm wondering about. Okay, so in order for you guys to get help from me, what do you need? You need your formulas, right? V equals v sub naught plus AT. God bless you. X equals v sub naught t plus 1/2 AT squared, and v squared equals v sub naught squared plus 2ax. And the reason why you need these is because, well, these are the only 3 formulas you get for the test, and for the next test, and for the next test probably. So these formulas are, they get around. They're good. In fact, these are not even called physics formulas. These are called kinematics formulas, which is just the study of motion. But we have to understand this to understand the physics. Okay, so my checklist here, I have v sub naught equals 0, v equals, I don't know, t equals 5 seconds, x is what I'm looking for. Little g I always know. I'm going to call it -10. I could call it +10, but then that would mean everything else that's downwards is positive for this whole entire problem. So by convention, basically we say down is negative. But now I have said, by putting this number in right here, I have said for the whole rest of this problem that down needs to be signified with a negative sign. Up would be positive then. Okay, so I'm looking at my formulas. What do I have? Well, I don't have a lot. I have time. So I need x and time in one. Oh, look, here's x. Here's time. Okay, I think maybe I'll use that one then. How about? Okay, so I'm going to use that formula. X equals v sub naught t plus 1/2 AT squared. The nice thing about this formula is it only has one velocity. And I know that at the top of any trajectory, my velocity is 0. And I can make that initial velocity anytime I want to. Even if it says final velocity, I can make it initial because that's the whole thing about physics. You have the math work for you versus you work for the math. So this one just happens to have an initial velocity of 0 anyway. So we just cancel it out. X, or displacement, equals 1/2 times -10 times 25. Okay, so x equals then -125 meters. Now you should look at your math and say, well, I got a negative number. That means it should be down because of what I said in the beginning. So is this displacement from beginning to end in the negative direction? Yes, it is. Probably the right answer. Any questions about that? Okay, so here's another example. V sub naught here, when you drop something right off the edge of a cliff, is going to be 0. So I'm just going to put in my V sub naught is 0. V, I don't know. Displacement is, I'm going to put -20. Now I have determined what direction is positive and negative when I did that. Right there. Done deal for the rest of this problem. I know it's going down. I called it negative. So now I can say my little g is also -10. You know, that's where people screw up. They don't follow their own convention, which, yeah, it takes a little bit of time. You know, it'd still work out if you had them both positive, but you might as well go with the convention down is negative. Left is negative. Okay, time is what I'm looking for. Okay, so I look at my three formulas. I think I'll probably use that same one because that's the only one that has time in it. V equals V sub naught plus ATS times 2. But if I start with x equals V sub naught t plus 1/2 AT squared. Okay. Now, if you want to use a quadratic, go ahead and just plug this into your calculator. If you don't want to use a quadratic, which I will ask questions which will force you into doing this a different way, then you're going to have to use another formula. So if you look at this right here, v squared equals v sub naught squared plus 2ax. Okay. If I have a 0 right here, I can figure out my v squared, right? Do you agree with that? Okay, so we'll do that. V then equals the square root of 2, and a here is little g, so it's a negative 10. And x here is a negative 20. Okay, so my velocity then is equal to 20, right? 20 meters per second. Okay, so we have 20 meters per second. So now we can plug that in up here as part of our variables, right? So now we have 20 meters per second. That's my final V. Okay, so now I can relook at my question. Oh, so now we can see that we have use for this. V equals V sub naught plus AT. So I guess when I originally thought this, I could use that too now, or I could use this. I could use either one. So then our time then is going to be V minus V sub naught divided by A, or our time is going to be 20 minus 0 divided by 10. Our time then is 2 seconds. Okay? Any questions on that? Tori brought up a good point here. Our final velocity is actually negative. Do you agree? And if you look back at our math, did we do the math wrong? Okay, thanks for the live interaction. So yeah, earlier we had v equals the square root, and we had a positive number under here. And so when I took it out, I just assumed it was positive, but any radical could have either a positive or negative root. Because the question came out of this, well, wasn't this one supposed to be negative 10? And yeah, gravity was supposed to be negative 10, which would give me a negative time, which is impossible, as far as we know, unless we have time travel. So how could this number be negative? Well, if you remember, we took our velocity out of the radical and we got 20 meters per second. Well, what I forgot to do, or maybe not, whatever happened was that we knew that the velocity was in this direction, and we knew that down was supposed to be negative. So at that point, we should have said, hey, this velocity is the negative root of whatever was under the radical. Okay, so does that answer your question? Okay, let's go on to the next one then. Okay, so this one, we're looking for displacement and time. Well, if you look at this number right here, v sub naught 35, your acceleration is what? Negative 10, right? Right away you can tell me how much time is it going to take to go up. So this should say x to the top. Should be the real question. How much time? Right away. 3.5 seconds, right? So you're getting that down. It's really easy when it's 10 versus 9.81. And then the physics comes into play versus the punching of the calculator. So if we were to do this with one of our kinematic equations, though, v equals v sub naught plus at. V up here equals 0, right, at the top. So then it becomes a negative v sub naught divided by acceleration equals time. In this case, the negative v sub naught is negative 35 divided by negative 10 equals 3.5 seconds. Okay? And you know, if you start at 35 and you're slowing down with an acceleration in the negative direction of the velocity of 10, well, it's going to take 3.5 seconds. Okay, but how about the displacement? Well, if you look at the displacement, you can use a couple of the formulas, v squared equals v naught squared plus 2ax, or I like to use x equals 1/2 at squared. So if I use x equals v sub naught t plus 1/2 at squared, this part right here can be then done as x equals, I'm going to show you two ways to do this formula. X equals v sub naught, so it's 35 times 3.5 plus, or I'm just going to put negative right away because I know acceleration is negative and I'm running out of board space. Okay, negative 5 times 3.5 squared. Okay, what do you get for a displacement? Okay, 61.25 is the correct answer. Now I'm going to show you one other way to use this formula, and this way might be more important. Okay, so if I want to make things easier for myself, then I'm going to start manipulating this problem. So instead of me saying this is v, I'm going to call this v sub naught, and I'm going to call this v, and I'm going to pretend like I'm dropping this thing. Because I know without a fact, up and down are exactly the same. We saw that in lab, we saw that in math, and now we're seeing it here. And you see it every day when you throw things up, right? So, if I take that same formula, x equals v sub naught t plus 1/2 at squared. Now, if I do it this way, my v sub naught equals 0 cancels out. Okay. X then equals 1/2 at squared. Okay. So x then equals negative 5 times 3.5 squared. X equals then a negative 61.25 meters. Same number, opposite direction, but remember what I did. I flipped everything upside down, right? So if I'm going to do something like this, I have to remember that, hey, I got to turn that back on its head the way it should be. 61.25 meters. Okay? Any questions on that? And last but not least, I guess there is still another way. So if you use v squared equals v sub naught squared plus 2ax, okay, up here we know v is 0, right? So that cancels out. So then we get a negative v sub naught squared divided by 2a equals x. So in this case, v sub naught squared is 35 squared divided by 20. And our displacement then becomes still 61.25 meters. I forgot to show that since I subtracted this whole thing right here, this negative is not a squared part of the value on this side. It's only the actual number that's squared. This negative is retained, so then when we have our negative 20 here, we also have our negative whatever that square is, and it becomes 61.25 meters.